welcome to the Chapter 5.2a lesson video. We're going to be talking about logs today, or logarithms. Now, this is a brand new topic for a lot of people. One thing I'm going to remind you guys of is if you were not taking great notes, you need to make sure you are taking really good notes. This is a topic that most people in this class have never seen before. And so you need to take the time, take good notes, pay really close attention to those fine details, write everything down, do the examples with me in order to help make sure that you improve and get better as this chapter goes along. This is often considered the hardest chapter of the year. So let's go ahead, let's dive on in. It's nothing to be afraid of. It's something that you can all master, but it will take time and effort. All right, so we're going to learn about introductions to logs. Today we're going to learn how to define and evaluate logs. This is kind of the baby steps introduction day. There's a bunch of rules and all these types of things. Today we're just going to kind of go into what are they mathematically and what are they kind of compared to something we already know. All right, so what is a log? Let's just start on this slide. This is a big old definition. We're going to kind of hash this out a little more in class, and I'll use some nice visuals to help you guys understand this a little bit better if you don't already get it after this video. So what is a log? Nope, not that kind of log, not like a campfire. A log is short for a logarithm. Logarithms are the inverse of exponentials. So exponentials, when I say exponentials, I'm talking about something like 2 to the x power. That is a good example of an exponential. Now, exponentials are something you talk about a little bit in other classes, and we've talked about this word inverse before. Inverse is something you're probably more commonly familiar with like addition, subtraction, multiplication to division, square roots to squaring. So this logarithm thing is the addition to the exponential's subtraction. It's the inverse. It undoes it. So just as subtraction is the inverse of addition, and division is the inverse of multiplication, logs undo exponentials, and exponentials undo logs. So let's go ahead. This is our first log written out right here. I'm going to tell you how we read it, how we kind of pronounce that out loud, and then we'll kind of talk about how logs and exponentials relate to each other and how you can write them. So the way you see this, log is log, so you say log, and then you say base b. So whatever the little number is below the log, that's the base. Okay, so log base b of a, so log base b of a. Oftentimes you'll see this a put inside parentheses, or whatever is there put inside parentheses, so keep that in mind. So log base b of a is equal to some number, x, or some variable, or something like that. Now, one important kind of note here, and this is something you might want to make sure you highlight in your notes. If no base is given, then we assume base 10. So base 10 is our default base. So if there is no b here, if it just says something like, let's make something up. If it just says like the log of 5 is equal to x, then what we're saying here is log base 10. That's just the most commonly used one, and so we don't often write that 10 because it becomes a little repetitive. The calculator that you're hopefully using, if you have a scientific calculator at home or if you have a cell phone calculator, more often than not, they exclusively use log base 10. They're incapable of doing other bases for logs. All right, so if you see nothing there, it's base 10. Otherwise, it's whatever the base is. And we'll talk about what that base is a little bit more in the upcoming slides. All right, so we talked and we said logs and exponentials are related. So here's how they're related. Notice there's kind of three working characters here. We have a b, we have an x, and we have an a. And this one has a b, an x, and an a. Between these two pictures, between these two sides, these are sort of equivalent expressions. All right, so we would say these are equivalent expressions. These expressions are the same as each other. They're just sort of rearranged. In the same way that if you had something like the square root of x equals 2, you could rewrite that as x equals 2 squared. That's kind of how exponentials and logs work. We can rewrite them. We can rewrite them in different forms. All right, so logs are just the exponent part of the exponentials. What we mean by that is when I say log base b of a equals x, that x is the exponent from the exponential over here. So b to the x power equals a. We can rewrite that. The b, the base from the exponential, becomes the base of the log. The answer to the exponential goes over with the log, and then the exponent becomes the answer. We can also go the other way. We can take the base from the log and raise it to the answer of the log and have it equal what was on the inside of the log. So we can kind of go back and forth. There's a really nice little animation thing. I wasn't able to put it in this video, but I'll show you guys that in class, and it kind of helps you see how these pieces move together. But the idea is that the base of the exponential and the base of the log are the same. The x and the a kind of switch sides. All right, so if you have an exponential, you can rewrite it as a log, or if you have a log, you can rewrite it as an exponential. So let's just go ahead and do an example of that. So first things first, I said, so this one right here, this is an exponential. We're going to rewrite it as a log, and I said the base is going to be the same. So I'll go ahead and say log base 5, because that's the base right here, of, and then we're going to switch the sides. So log base 5 of 125 equals 3. Okay, and then the other way of doing things, this is a log. We're going to rewrite it as an exponential. So when we rewrite it as an exponential, it should be a true statement. You'll kind of see that in a second. We're going to take the base of the log. The base of the log is this 2 right here. So we're going to say 2, and then we're going to go to the other side, the 3, the answer there. 2 to the third power equals 8. All right, so here's the question that I'm going to ask you guys over and over and over when it comes to logs. Okay, and it's a really nice way to kind of think about it as exponentials. If you're in a log form, you say 2 to what power equals what you're taking the log of. So 2 to the third power equals 8. 2 to the third power equals 8. That's how we rewrote it as exponential. Or if you're in exponential form, you're going to say the log base 5 of what power equals 125, so log base 5 of 125. What power is going to make 5 become 125? 5 to the third power, and that's what we saw right here. And so that's how we're going to kind of evaluate these here in a second, is we're really going to kind of always kind of go back to this exponential form, because that's what you guys are more used to, and we're going to use that to help us evaluate them. So this first piece here is really just wanting to be able to go back and forth. The key is the base stays the same. So the base of the exponential is the base of the log. And then the exponent of the exponential becomes the answer of the log. And the answer of the exponential becomes the kind of input of the log. Or going the other way, the base of the log becomes the base of the exponent. The answer of the log becomes the exponent of the exponential. And the input becomes the answer of the exponential. All right. So let's talk about evaluating logs. So we can evaluate logs by setting it equal to x. So we're saying, what does this equal? If I were to plug this into a calculator somehow, what would the answer be? Now remember, I told you that most calculators only do log base 10. They don't do things like log base 5. So really, you shouldn't have a calculator that can this can be plugged into. And so you're going to have to show this work in order to really get your full credit. So the first thing you're going to do is you're going to set it equal to x. And then because we know how to change this to exponential form, that will really help us here. Logs are kind of confusing to conceptualize, but if we can switch them back to an exponential form, we can really kind of evaluate something here. So let's go ahead and do that. So the base is 5, so the base of my exponential form is going to be a 5. I'm going to take the answer, which is that x, that thing on the other side. I'll make that my exponent. I'm going to say equal to the input of the log. That's the 125. The thing that the log is being taken of. All right, and now we're left with this question. 5 to what power equals 125? And, well, most of us kind of know this. This is something we should know. 5 to the third power. So that means this x value has to equal 3. So what does log base 5 of 125 equal? Well, we can go ahead and erase this x now. We can say it equals 3. And this is how you show your work. Okay, so log base 5 of 125 equals 3. We found that using this process. We said, all right, this is equal to x. We changed it to exponential, and we answered the question, and then we can go ahead and make it equal to 3. So if you had a calculator that could do log base 5, you could do log base 5 of 125, press enter, and it equals 3. Now, there are some calculators out there that that do this problem for you. They can change the base. Not every calculator, most of your guys' calculators, most of your phones won't be able to do this. However, if you want full credit on these problems, I need to see some sort of work like this shown. If you're not showing this work, then you're not going to get your full credit on this problem, okay? All right, so here's a couple practice problems we're gonna go ahead and do. Nothing too crazy. I'll go ahead and walk through each of them fairly quickly. If you wanna watch this part over and over, get some more practice, that's totally fine. All right, so this first one right here, log of 1,000. Now, we already kind of talked about this. If there is no base given, we can go ahead and fill it in. I'm going to go ahead and fill it in as a 10, so log base 10 of 1,000. You don't have to write that 10 in. We all kind of assume that and know that. We'll say that equals x. We'll rewrite this as an exponential, so we're saying 10 to what power equals 1,000. Now, after a while, you guys are going to get better at these, and you're not going to need to show this work. You could potentially do some of these in your head. You could say, all right, 10 to some power equals 1,000. Well, I know how multiples of 10 work. 10 times 10 is 100, and 100 times 10 more is 1,000. So that'd be 10 times 10 times 10. So I know that this x has to be 3. Right? So some of us could probably already even do that in our head. 10 to some power equals 1,000. Well, that's some power that has to be a 3. And so you would go ahead and find that x is 3. So this log base 10 of 1,000 is equal to 3. Now, I still need you to show your work. Even if that's some problem you can do in your head, I'm telling you guys now, you need to show your work if you want full credit on these problems. All right, let's keep on going with these. This next one, log base 12 of 12. All right, so we'll make it equal to x again. We'll say 12 to what power equals 12. So 12 to some power equals 12. Well, this is pretty easy. To get something to equal itself, that exponent up there has to be a 1. So x equals 1. So the log base 12 of 12 is equal to 1. All right, so we could change that x to a 1. All right, let's keep going. There's some other tricky ones, slightly trickier ones here. Log base 2 of 1/8. Now, this is a little weirder. So we'll go ahead and say x. So we say 2 to what power equals 1 over 8. Now, this one I think is a little trickier for people sometimes. I see this, I kind of know, just because I have a lot of experience with this. I know 2 can become an 8 by raising 2 to the third power, right? So 2 to the third power would be 8, but 8 does not equal 1/8. So I need to think of something else here that'll help me out. How do I use exponents to reciprocate this or flip this upside down? And hopefully it comes to mind, but negative exponents, if there was a negative number up here, it would reciprocate it. So it's not just a 3 to get that 8, it's a negative 3. So here, x will be negative 3. What that negative 3 will do is it'll cause the 2 to reciprocate, and then 2 times 2 times 2 is 8, so that makes the 1/8, and that'll give us our answer that we're looking for. So this x here, the log base 2 of 1/8 is negative 3. All right, and then the last one is a little bit of an interesting example. The log base 4 of 4 squared, we'll do the same thing. We'll say equal to x. We'll say 4 to what power equals 4 squared. Well, this is a little silly. 4 to what power equals 4 squared? Well, that missing piece there has to be the same. They have to match. These sides have to be equal, so that x has to be 2. And so we know that this missing x right here, what does log base 4 of 4 squared equal? It has to equal 2. It has to equal squared. Now, there's a couple other tricky ones that'll pop up, and you might see this on your homework or something like that. If you ever have a log base anything of 1, it has to equal 0. Because the only way we can get something to be 1, right? So b to the 0 power, that's the only way you're going to get a 1, right? Because 0 power equals 1. So this is kind of an interesting one. So it could be the log base 1,000,000 of 1 equals 0. So log of any base 1 equals 0. It's kind of an interesting one that you will see every now and then. All right. All right, one last little thing here, and we kind of saw that with the last example, or the second to last example before I was talking about that special case there, is this. The log base b of b to the x is going to be just x, or b to the exponent of log base b, x, is going to be just x. Logs and exponentials are inverses, right? This is called the inverse property of logs. We said this from the beginning. Logs and exponentials are inverses. Since they're inverses of each other, they kind of undo each other. So you can kind of think of it as the log base b gets rid of the exponential base b, leaving us with just the x. Or the exponential base b gets rid of the log base b, leaving us with just the x. So just a trivial little example made up. The log base 7 of 7 to the 11 will equal 11, right? The log base 7 and the exponential base 7 get rid of each other and leave just 11. Or another way you could see this is you could see it something like 2 to the log base 2 of 25 will equal just 25. The exponential base 2 and the log base 2 are inverses. They undo each other, leaving us with just that 25 that was there. All right, with that, you should have enough to get started on this first assignment. This was a quick introduction to logs. If this was really confusing to you, watch the video again, practice, try, get the homework out while you're watching it. Look at the examples that I'm having you do there. It's a lot of practice on evaluation and just switching back and forth between the forms. I'll be glad to answer questions. If you have any questions, reach out. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.